This is the introduction to section 2.1. We set the groundwork in the rest of chapter 1 to be able to go back to our idea of slopes of secant and tangent lines and try to formalize finding the slope of a tangent line. So the first question here is, can we find the equation of the tangent line to f of x equals x squared minus 1 at x equals 1? It's written as a statement. I guess we should change that. It's not a question. Let's just go ahead and do that. Okay, so I started the drawing already. First I said, okay, well, I got to find a point on that tangent line, and the point's going to occur when x is equal to 1. So I evaluated f at 1, got an output of 0, and that point on the tangent line is the point graphed at 1, 0. From there, I sketched in the tangent line in blue. That's what we're trying to find the equation of. But I don't have enough information to go ahead and find the equation of that line. I only have one point on that line. So I went ahead and drew a general secant line to this curve as well. I went to a random x value right here, went up to the curve. That point then has coordinates x and the output of the function, which is x squared minus 1. And I can find the slope of that secant line. So let's go ahead and do that. So the slope of the secant between 1, 0 and x comma x squared minus 1. Well, that slope is change in y divided by change in x. And again, this is the slope of the secant. And so the y direction looks like x squared minus 1 minus 0 divided by, in the x direction, x minus 1. Okay, so the question then becomes, how can we use the slope of that secant line to find the slope of our tangent line? Well, what do we need x to do? We need this point on the curve to move closer and closer to the point 1, 0. And that's going to occur if x goes ahead and moves along the x-axis here towards the point 1. It looks like we're only approaching from the right, but I could have drawn my secant line on the other side. So we want to know what happens if all of those secant lines when x approaches 1. So the slope of the tangent, let's see, so we need to let x approach 1, and then that will give us the slope of the tangent line. So the slope of the tangent line happens when x approaches 1. So we take the limit as x approaches 1 of the slope of the secant line. Okay, so again, we found the slope of a secant line. We want the value x to approach 1. And if it does, that point's going to move down the curve, and our secant lines will look more and more like that tangent line. And if we can evaluate this limit, we will get the slope of the tangent line. And this is a limit that we saw how to handle previously. So this is the limit as x approaches 1 of x minus 1 times x plus 1 divided by x minus 1. And we should be able to quickly see that that limit is 2. And so now our tangent line, we have all the information we need to write down the equation. It goes through the point 1, 0, and it has slope equal to 2. And so its equation is y minus 0 equals the slope 2 times x minus 1. Okay, so there's an example of finding the equation of a tangent line. And I'd like to go ahead and formalize that idea a little bit. Okay, so let me draw a picture here. So the question is, if P is the point A, f of A, and Q is the point x, f of x, what is the slope of the tangent line at A? Okay, so let's draw a picture. Maybe we have some function that looks like this. And here is the point, let's change colors. Let's say here is A, and here is x. And so here is the point x, f of x, and here is the point A, f of A. Okay, if I find the equation of this line between those 2 points, that would be the equation of a secant line, but what I'm really trying to find is the equation of this not exceptionally well drawn tangent line. And we'll do something very similar. Up above here, we have the same exact example, or similar example, and we let x approach 1. So down here, we would just let x approach a after we find the slope of that secant line. So let's go ahead and do that. So the slope of the secant line is the change in y, which is f of x minus f of a, divided by the change in x, which is x minus a. Okay. And again, like we let x approach 1 above, we want to let x approach a, in this case, if we're generalizing. And that would get us then to the slope of the tangent line as the limit as x approaches a of f of x minus f of a divided by x minus a. Okay, so there's a generalization for finding the slope of a tangent line. It's the limit as x approaches a of f of x minus f of a, and that is the slope of the tangent at the point a, f of a. Okay, so that's the one big idea. It's finding slopes of tangent lines. There's one way we can approach it. I'm going to change up the idea ever so slightly here and show you a second way that we can approach it. This one was hard to draw, but hopefully you get the idea. So this says find the equation of the tangent line to square root of x at x equals 4. Okay, so first thing I did is I evaluated the function at 4. I got 2, and I know the point that I'm working from then is the point 4, 2. I sketched the tangent line in blue, and I drew a secant line in orange. But instead of moving over to a point x, f of x, I moved over to a point 4 plus h, and then the output of the function 4 plus h. So now I want to find the slope of the secant through 4, 2, and 4 plus h, square root of 4 plus h. I just moved over h units on the x-axis. I don't know what h is. It doesn't matter. It's holding a place value to draw in a secant line. Okay, so the slope of that secant then is change in y, which is square root of 4 plus h minus 2 divided by 4 plus h minus 4, which looks like the square root of 4 plus h minus 2 divided by h. Okay. As before, we let x approach 1 on the axis. Here we want this point 4 plus h to come in this direction and get closer and closer and closer to 4. And so to do that, what do we have to let h get closer to? Well, for 4 plus h to approach 4, h has got to approach 0. And that would allow us to find the slope of the tangent line. So we want to let h approach 0. And we will get that the slope of the tangent line is the limit then as h approaches 0 of the square root of 4 plus h minus 2 divided by h. Okay, another limit we can handle. We saw limits similar to this, and we'll need to multiply by 1 in this fashion, square root of 4 plus h plus 2 over the square root of 4 plus h plus 2. And I'm going to do the algebra. Oh, sorry about that. I'm going to do the algebra quickly. This is the limit as h approaches 0. We're going to get 4 plus h minus 4 in the numerator. So you should see that that numerator simplifies to h divided by h times the square root of 4 plus h plus 2. These things are going to go away, and we can evaluate this limit at 0. And it looks like we get 1 over the square root of 4, which is 2 plus 2, or 1/4. Okay, so then the tangent line at the point 4, 2 has slope 1/4, and so its equation looks like y minus 2 is equal to 1/4 times x minus 4. Okay, I want to generalize this idea also. Slightly different, same idea, finding the equation of a tangent line. We just changed this general point x, comma, the output of the function, to 4 plus h, comma, the output of the function. So we have a similar idea here. We're going to draw a picture. We draw pretty much the same picture as before. And we're starting at some point a, comma, f of a. Here's another point, which on the x-axis is a plus h. So this is the point a plus h, comma, f of a plus h. And we're going to use this secant line to help us find the equation of this tangent line. Okay, so the slope of that secant line then, well, it's the change in y, which is f of a plus h minus f of a divided by a plus h, change in x, minus a. So this is f of a plus h minus f of a, all divided by h. Okay, and then again, we want this point a plus h to move along the x-axis and get closer to a. And the only way it can do that is if h approaches 0. Our tangent line, our secant lines will look more and more like our tangent line, and we get that the slope of the tangent is the limit as h approaches 0 of f of a plus h minus f of a divided by h. And again, that's the tangent at the point a, f of a. Okay, so we've seen two ways to find that tangent, and that slope of that tangent line has a name. It's defined as the derivative of a function at x equals a, and we can find it two ways. The second way we just saw is the limit as h approaches 0 of f of a plus h minus f of a. And the first way we saw, sorry, this limit is incorrect. Let me fix that instead of retyping. This should be the limit as x approaches a of f of x minus f of a over x minus a. Okay, see if you can use that to find some slopes and equations of tangent lines on the section 2.1 activity.